maybe somewhere in the middle of the Atlantic, it's, Friday midday afternoon. So week 16, we are getting closer and closer to the end of our journey. And that's why today for Kevin and Hobbs, we have a bit of a, misty-eyed strip saying, if good things lasted forever, would we appreciate how precious they are? Obviously not. So we know all good things have to come to an end, but that's what makes them special. We do still have a couple of weeks. I will pause this for. I don't think, Vicky, I don't think anyone cares for this slide anymore, but
Well, just for the record.
I'll do,
I
yeah.
mean, we have one more week, I believe. One more week.
Well, this one and the next one, that's what I'm saying.
That's not a couple of
And
weeks.
a couple is two. That's what a couple means. Anyway, so a quick reminder that we still have office hours, although I have removed the names because I have no idea who is holding these office hours. I suppose Dieter is doing them, although last time, I don't know, was it Nick? Because I know you did some fancy chocolate stuff.
Right. I was busy, so Nick took mine, I took Emma's.
Okay, okay. But
And
still,
then Dieter didn't share any of his chocolates with us.
oh no, Dieter, come on. That's bad.
You can come over after work and get some, or
Well, at
before
least
work.
are the chocolates good? Did you end up with good tasty
Yes,
chocolates?
yes, they're edible.
Okay. Okay, good. Edible is, not much of a. All right, edible. Let them be edible. So today is week 16, next week is week 17, and these 2 weeks we're going to talk about object-oriented programming, or OOP for short. We will not be able to cover everything in 2 weeks because it's like an entirely separate topic. It's quite different from what we've done previously, but at least we'll do an introduction and try to go a bit in depth next week. But as usual, Vicky giving up stuff left and right. So we have another quiz. Once more, you will see a couple of images, or Vicky, two images if you don't like a couple, two images from a certain location. And as usual, the first person
Different
to
missing
write
place.
this,
This
the
will be the last
city.
one.
Okay,
Um,
this is the last one.
this will be the last one where you can actually win a t-shirt if you want. So,
Okay,
30
so you
seconds.
just need a city, and as usual, here are the images. Let's go.
This should be pretty easy, I think.
Well, I'll tell you immediately, I have no idea what the answer is, so you'll have to provide the answer.
Oh, close. You're in the right geographic region, but
Okay.
it's not Shanghai, China. Any other takers? I mean, if anyone knows like where I was born and grew up, you'll get this. You're all in the right geographic area, but um,
Which is basically plenty. So keep digging, guys.
um, okay, I guess no other taker. Even Steve, the world traveler, couldn't figure this out. Okay. That is pretty. So, Alex, you care to venture a guess?
Me, I have absolutely no clue. I mean, obviously, it my first thought it was somewhere in China, but I have no idea more
Okay.
specifically, and I'm
Um,
not even sure whether it's China.
and so Leah did get the country. Okay. It is Taiwan. This building is the tallest building in Taiwan. It's called Taipei 101. And on the top of this building, you see this big yellow ball. That's like an earthquake damper because Taiwan, I think, is very close to a fault line, and so there's a lot of earthquakes. And so the city is actually Taipei, which is the capital of Taiwan. And yeah, there's not that much to be said about it. I was born there. I went there in April. Has really good night market. I hope you guys will visit it at some point. Really great tea, friendly people. So
So Yerevan, Armenia was easier. At least two people got, but
I did
with
not.
Taipei,
I wouldn't have thought that because this is actually, I don't know. Um, Yeah, I mean, there's that. Oh, the other thing is there's actually a hotel, like a five-star hotel, the Grand Hyatt, that's very close to Taipei 101. And rumor has it that that hotel is severely haunted, and a lot of online reports will say like weird things happen when you like stay at that hotel. And so I don't know why the hotel is still a five-star hotel in business. Um, because
maybe that's the exact reason.
because supposedly when Taiwan was under Japanese occupation, that used to be like an execution ground or something like that. And so I've never had the guts to stay at that five-star hotel, but if you guys visit Taiwan, maybe you can like stay there and then tell me if anything.
And live to tell the tale.
Yeah, I mean, there's plenty of people on Yelp that live to tell the tale, but they just have like very weird stories to tell. So,
All right. So the plan for today, we're going to do introduction to object-oriented programming. And when I wrote here 1 hour, I actually believe that that could be the case because we're going to go into it in depth. It's a topic which does require a bit of depth, and a very slow descent into the topic. And then there were a couple of assignments. I think one of them we'll do together. The second one we'll do in a breakout room, then do the solutions. And if we have time remaining, I will also show you like in a mini project that is actually more not useful, but you would actually see how it would work in a mini program. Use object-oriented programming and not the typical programming we used before. So, object-oriented programming. I would encourage you guys to ask questions as soon as they pop up because there will probably be, places where you go like, what? And please do not hesitate to ask. I mean, this will probably require questions. Anyway, let's start from the beginning. When we talk about object-oriented programming, what are we talking about? And object-oriented programming is a programming paradigm that focuses on objects and their interactions with each other. And this obviously sounds like gibberish. Like, what does that even mean, focusing on objects and their interactions with each other? So let's take a look at a very specific example that I hope many of you will immediately recognize. Here it is. Take a look at this screenshot. I hope many of you recognize this as Super Mario. So the question to you is, what objects do you see in this Super Mario screenshot? You can answer via voice, you can answer via chat. What do you see? What would you classify as an object in this screenshot? Okay, we see Mario. Mario could be classified as an object. We see bricks, a pipe, a mushroom. We see the scores. We see the background. Steve, speak up. No need to raise a hand.
I think almost everything's an object.
Okay, but more specifically, like what else?
Okay, like okay, the little bricks that you walk on, the little ball on top, the question marks on there, even on the top. I'm guessing the things that are giving you statistics and time.
Right, yeah. Okay,
That
what else?
little that
I
little what
mean,
is it? The right thing on the
ma-
bottom. What is smoke? What is that? The little green thing that he can jump in the pipe or
yeah,
whatever.
yeah, there is a pipe or there is like the piece of grass. There is one thing that nobody is mentioning, which is important,
The
because
background.
well, the background as well. That's like the cloud is part of the background because
Okay.
words. Well, you could say words as well, like everything that's on top. Like the statistic line is a separate object as well. Well, color is not an object per se. It's probably an attribute of this or that object. So an object of a certain color. But no one's mentioning the ground that Mario is standing on. So this is also important because it's an object which actually allows Mario not to fall through to the bottom. So, but otherwise, most of the things that you wrote or said are true. So Mario is a separate object. Then, oh, I don't know where the enemy went. There was supposed to be an enemy here. There was supposed to be a little Goomba, but he disappeared for some reason. I don't know why. But enemies are obviously also objects in the game. You have different blocks or bricks. You have the mushroom, you have the pipe, you have the ground and the grass, you have the background, which is sky, the clouds and the hills. And on top you have, game information as well. So all of these are objects. So now each object in that specific game and in object-oriented programming in general, first of all, has its own properties, or you would also say those properties describe what state the object is in. And also each object has certain behaviors. And the behaviors specify what actions the object can perform. So each of the objects has a state, and many of the objects has behavior, what they can do, unless it's a completely inert object, in which case it does not have any actions associated with it. And in programming, and specifically in Python, the properties of any object are called its attributes, or another term that's used is instant variables, and an object's actions are called methods. And methods is actually a term that we have already encountered before. Do you actually remember where the word methods was used? Where did you use the word method? Does anyone remember? What do you call a method?
Functions.
Functions, exactly. So methods are functions, but why do you have separately functions and separately methods? What's the specificity of a method as opposed to a function?
We applied some to strings.
For instance, you're correct. Like string methods apply to strings, but do we have other data types that have methods?
Sets.
We have set methods, we have list methods, we have dictionary methods, etc., etc. Absolutely correct. So the difference is that methods are, as Vicky said, functions, but they are for very specific data types. And the reason why in object-oriented programming actions are called methods, because it's the same thing. So methods are functions for a specific object. And we'll talk about a bit later. Yeah, Vicky.
So I just wanted to make one comment because I don't know this is technically correct, but when I started learning OOP last year, this kind of helped me think about it. So this is something that my daughter told me, okay? And so my daughter said in object-oriented programming, you have something called a class, which I'm sure Alex is going to talk about. And so class is like the blueprint. And so if you're talking about, if you're using the analogy of a car, okay.
You're running ahead. I'm going to talk about all of this. Why are you
I
doing
know.
this?
Okay, just let me get this over with so that if I need to go back to sleep, I could leave in peace. Okay. So Blueprint is the class, and then if you build these, I guess like object within the class, it's like you're building a specific car from the class, right? And then I was very confused about these attributes, but then she told me you can think about attributes as adjectives that describes your class, like size of the car or the brand of the car or the color of the car. And then methods are like verbs, okay? Because methods always like do something. So I just thought that analogy was useful to help me think. Okay. Sorry, Alex.
Okay.
move on.
Thank you, Vicky. All right.
Thank my daughter.
So I'm going to answer a question in Blossom. I see your question. You're saying like methods are like aren't methods algorithms? I would think methods would be algorithms. And in a strict sense, yes, but functions are also algorithms. An algorithm, it's something that's, solves a certain, well, not a problem. It's just a collection of steps that in the end reach a certain result. And in this sense, every method is an algorithm. It could be a very simple one, a complex one, but also functions are algorithms, etc., etc. So the specifically methods are applied to a specific data type. So like we said, a list method can be used only on lists. A dictionary method can only be used in dictionaries, and a class method can only be used on objects of that class. We talked about specific.
Thank you.
No problem. We talked about objects that we see in a Mario game. So now the following question: what important properties do you think, or attributes, that would be the correct word? And remember what Vicky said. So attributes are something that would describe that object. What important properties does Mario have? Okay, so we have size, we have color. I don't think color is important, but he does have color. Movement. When you say movement, what do you mean by movement?
I mean, he could be like, well, I don't know if this is actually attributes or actually methods. He could like jump, he could throw like fireballs, he could like
Those are methods. Those are
jump.
methods.
Okay.
And that's a method as well. Because those are verbs, you said yourself. Like, verbs are methods, and adjectives are, not necessarily adjectives, because size is not an adjective. Size is a noun. Mario's location
yeah.
in the game, excellent, Dieter. That is important. Yeah, because his coordinates or his location, that's a very important property. Size is important because Mario can be small and Mario can be large. What else? Anything else? Try to remember what else is in the game that's important about Mario.
What superpower he has?
Yeah, whether he has a superpower or not. In the basic game, there is only one. You have the fireball, so it's whether he has the fireball or doesn't have the fireball. So XY position, yes, that's the location, exactly. Since it's a 2D game, it's enough to have two coordinates, an X and a Y. So here are my answers. I'm not saying that these are the only ones. So coordinates, of course. Then speed and acceleration. So that's what's important about movement. At every point in time, Mario is either standing still or moving at a certain speed in one or another direction. And this can be both horizontal and vertical, for instance, if he's jumping or falling. And also you need to track acceleration because the speed is not constant. You can hold a button and run faster. So that's also to be accounted for. Size we mentioned, fireball power we mentioned. The number of lives, so how many lives Mario has, that's also important. The number of coins he has. And Vicky, you mentioned color. Leah, you're mentioning clothes. This is the image sprite, basically. Yeah, what image sprite you're using to show Mario to the player. For instance, to differentiate between Mario and Luigi or Mario and Wario, etc., etc. So that's also correct. Now, this next question is, Vicky already started on this and has a question or a comment, so shoot first.
Yeah, so I was wondering if you have two different programmers, programming the same object. Okay. I mean, it's very likely that they would come up with slightly different attributes for the same object, right?
Sure, probably. Well, depending on, where they're coming from. If they have a document upon which they're building this, and this is usually the case, you first write out a technical document and then only start programming based on this. So depending on the quality of that document, they would either have the same stuff or different stuff.
Okay. So I guess in terms of like the attributes and methods for any given object, there's no absolutely right answer, right? I mean,
Like with anything in programming, there is never one absolute answer. For any assignment, any problem that you have, you would most assuredly have different solutions by different programmers. So programming is an art as it's a science, and you are correct in this. So my next question to you is like, what important actions, or in our case, methods, can Mario perform? And Vicky mentioned some. Moving is obviously an important action or method. Jumping is an important action or method. What else can Mario do? Run, jump. I have no idea what squash is. Oh, you mean like
well, he could duck.
land on someone?
Y-
Duck,
Well,
yes.
yes, he could duck and then he could like, step on something and like squash it.
Right, but there is no different action for squashing. That's actually jumping. You have to jump
Oh,
and
okay.
land on someone.
That's fine.
And the squashing is actually the result of interaction between several objects, and we'll talk about this in a minute. As well as growing big. So there is no action. Mario cannot grow big by himself. It's an interaction of Mario with a mushroom. Then he becomes big. Actually, going down the pipe, I would probably say that ducking on a pipe gives you this result, or die. Die is also like it's a passive thing. He dies in certain circumstances, but that's certainly true. So I think we covered most of them. Move, yes. There is also accelerate. So it's a different action from moving because you move at a constant speed, but acceleration allows you to increase that speed. So that's a different method. Jumping, shooting fireballs if you have the fireball power, and ducking. I do not know of any other active actions that Mario can take in a game. Everything else is a combination of several objects interacting with one another. So now some questions in that vein. So once again, Vicky sort of started talking about this. So what happens when Mario's top coordinate, so his head, intersects with a block's or a brick's bottom coordinate? What would happen in the game world? So Mario's head hits the bottom of a brick. The block, usually the block either breaks, so that means the destruction of the brick. What would actually happen to Mario in this case? If Mario hits a block.
Nothing.
So Mario continues moving upward through the block.
Oh no, he falls back down.
Yeah, so that's what happens with the interaction. So first of all, the block's attributes change. So the block either breaks and is destroyed, or it produces a power-up, and in this case, it usually turns into a metal block that cannot be destroyed. So its attributes change, its state changes. And Mario's attributes also change. His speed changes and his acceleration changes because now he's moving in a different direction with a different acceleration. So another question, what happens when Mario's coordinates intersect with the mushroom?
Oh, he gets big.
He gets big, so that's what happens with Mario. His size changes as an attribute. What happens to the mushroom?
The mushroom disappears.
The mushroom is destroyed as an object in this case, yes, because supposedly Mario scarfs down that mushroom in one big bite. So you once again see how two objects interacting with each other affect each other's attributes. Question number 3, what happens when Mario's left or right coordinate intersects with an enemy?
I think that depends on the enemy.
Not really, no. I think
I
all the
mean,
enemies
Mario
in Mario
dies.
act the same. Well, either Mario dies and loses a life, or if Mario is of a big size, he
It becomes smaller.
one or another. So Mario's attributes change. The enemy's attributes usually do not change, at least if he dies, but sometimes the enemy changes the direction of its movement, so it starts moving away from Mario after he touches Mario. Last question, what happens when Mario's bottom coordinate intersects with an enemy? So that's what we're talking.
Oh, and then the enemy as an object disappears.
Yeah, the enemy is squashed. What happens to Mario?
Nothing.
So he just sort of boom, lands on the enemy. This is a bit harder because he actually does get a change in speed acceleration, because once you jump on an enemy, the dead enemy pushes you up a bit. So you can actually perform a mega jump if you time your jump at the moment where the
Really?
enemy is hit. Yeah,
Are you
but
sure?
this is details. No, I'm not. I don't care in truth, but I think you can. Yes, I think if you jump on a turtle, for instance, you can jump off the
Okay.
turtle's shell and go higher. But I haven't played it for quite some time, so I might be misremembering. So I hope this gives you sort of an idea of what it means when initially I said that object-oriented programming is about different objects interacting with each other. So objects interact with each other, changing each other's attributes using the methods that they possess. And now we will talk about something that Vicky previewed. We're going to talk about two things, classes and objects. So classes is an important concept in object-oriented programming. So far, we've talked only about objects. Now it's time to talk about classes. And in object-oriented programming, a class, like Vicky said, is a blueprint for the creation, or it's also called instantiation, of specific objects, which are called class instances. So objects are instances of a specific class. And once again, without a specific example, this could sound like gibberish. So let's look at a specific example. Before we do that, yes, a class actually describes attributes and methods of every object of the class that the class have, that the objects of that class should have, and what the attributes are at the moment of the object's creation or construction. It's also called an object's construction. And each specific object or each specific class instance stores its own current state. So if you have several objects, like you have several enemies in Mario, even though those enemies come from the same class, for instance, they're the same enemy type, each of those enemies has its own current state. So one moves in one direction, the other one moves in another direction, the third one is falling, the third one is dying because Mario just stepped on it, etc., etc. So objects are separate from each other, but they all come from the same class. And the interesting thing is that in order to understand classes and objects, you can actually compare classes to data types. So we know data types like int, list, dictionary, set, float, string, etc. So class data types. And objects are specific values of those data types. So for instance, the number 5 would be a specific object of the class int, or the string hello would be a specific object of the class string. And I'm actually, yeah, for instance, if you look at int as a class, the objects of that class would be like 5, -17, 0, etc. For the str class, you would have the string hello, or the string with a single letter A, or an empty string that would also be an object of the class str. If you take a list, you could have a list values, a list of one value, or an empty list. And for instance, had a class describing, this mushroom creature, Goomba, the enemy. You would have a class which would describe, what it looks like, what are its attributes, like its speed, its coordinate, etc., that they're supposed to have. And then you would have specific Goomba instances. Those are the specific enemies different from each other, which you see on the screen. And so that's the difference between a class and objects of that class. So Vicky, you're asking, is there any difference between objects and instances? Class instances, then no, it's the same thing. Those are synonyms. So an object is a class instance, as far as I know. And the reason why I gave you this comparison of data types and values to classes and objects is that actually, data types and objects, data types and values are classes and objects in Python, because everything that exists in Python is actually an object of a certain class. So for instance, if we create 4 variables, one is an integer, a string, a list, and one of our Goombas, and then for instance, if we print the type of the first one, type is a function which actually gives you back what the data type is. You will see this kind of weird string which says class, but the reason for that is that there is actually an integer class in Python, and all of the integers that we use are actually objects of this class. The same would apply to string, so you'd get class str, you would list, and you would have class, in our case, enemies.GoombaEnemy, because enemies is the module from which it's imported, and GoombaEnemy is the name of that specific class. So this is important to know, because really everything we've used in our programs is actually an object, but we never thought about it because we never needed to think about it in this way. And a visual representation of this, if you look at this screenshot from a Lego manual, of the things that you see on your screen, which one do you think is the class, think is the object or objects? Let me know either in the chat or via voice.
I think that in white, where they have the different elements, that's the class, and the 2 that are completed are the objects. Yeah.
And you would be absolutely correct, for the simple reason that the image on the left is not actually a specific thing. It's not a specific object. It's an instruction on how to build an object. While on the right, you have very specific instances which may look different from, this image. So the guy on the right is obviously not the same as the guy on the white background, but you still sort of understand the logic. And the logic is that, let's say we have a class which is called Lego figurine, and this class describes that its objects or class instances have the following attributes. The attributes are, it's supposed to have 1 torso, it's supposed to have 1 set of legs, it's supposed to be 1 head, there is supposed to be 1 head accessory, and there could be an optional hand accessory, but it's not necessary. And then we look at the specific objects which are created from that Lego figurine class, or of that Lego figurine class, and each of those objects has one very specific torso. So one has the shirt and the other one has the orange jacket. They have 1 specific set of legs, different color, 1 specific head, 1 specific head accessory. So here it's a hat, here it's hair, and 0 or 1 hand accessory. So the orange guy doesn't have any hand accessories, but this one has a briefcase. And these are 2 separate objects of the Lego figurine class. So they're built from the same blueprint, but they're totally different objects. Well, they're like 2 different people, 2 different figurines. Now let's take a look at another example, and Vicky mentioned this as well. Today my mic is not working. I have issues with the earpods. Well, Flora, if you can type, then type. I don't mind if you can speak. So take a look at this image that you have on the screen and tell me, do you think this image represents a class or an object? What's your opinion?
Class.
Why? Why do you think it's a class?
Because it looks like a blueprint. I mean, unless I'm not very good at telling art. To me, it looks like a blueprint rather than a specific car.
And that would be the correct answer, because obviously this is not an image of a real car. You don't have cars which are drawn, in pencil or what have you, that are transparent and you can see like the insides and the other wheel, etc., etc. So this is obviously a blueprint. So this is a visualization of a class. If we were to call this class, what would you call it? You would say this class is called
Car.
Car. Exactly, because you understand that this is a blueprint for a car. You know that cars have 4 wheels, and you know that they have like doors, and they have a steering wheel, and they have the mirrors, and they have the antenna, etc., etc. So this class would be called car. Now, the first question, if we were to talk about the car's attributes, remember, attributes refer to, the state of the car, what the car is, as opposed to what the car can do. What attributes would you mention? What attributes does a car have?
Size, um, speed, color,
Okay.
like brand,
Yeah.
um,
Amount of wheels,
yeah, oh yeah,
materials. Yeah.
wheels. I mean, if you want to
Usually
get
Apple
it's four,
Car
but not always.
Apple CarPlay.
Whether there is Apple CarPlay or not, or whatever the system is, the model was
horsepower.
launched. Horsepower, there you go. Anything else?
I mean, the list can go on and on and on. I mean,
Exactly, exactly. You can go on and on because cars are quite complex as objects, and a class would also be quite complex. So some of the things I put down was size, like width, height, and what have you, length. Horsepower mentioned, brand mentioned, acceleration, how fast it can go, its weight, its the mileage is a thing that would actually change. The more you drive the car, the more your mileage would be. How much gas it has in the tank if it's not an electric car. What's the trunk space? What's the speed? And you also mentioned like color. You also mentioned number of wheels, etc., etc. So those are all correct answers to the question. So now if we were to talk about the car's methods, what kind of methods would the car need to have in order to perform?
it needs to run.
Okay.
The
Running.
door needs to open.
True.
You need to go forward, backward, stop, brake. You need to have air conditioning. That's very important.
So turn on or turn off air conditioner, which could also be
Like,
an attribute, whether there is an air conditioner or not.
you need to be able to turn on headlights.
That's true. Flora, you're saying why are horsepower, speed, acceleration objects? We didn't say they were objects. They are attributes. So attributes describe the state of the object. So you're saying that this object has this much horsepower, or it has this speed, or it has this acceleration. And methods will affect your speed, and methods will affect your acceleration. Probably methods will not affect horsepower because horsepower is set, unless there is some method, like turbocharge your engine, and then you have more horsepower than initially, etc., etc. So some of the methods mentioned are absolutely correct. So these are the ones I had, like you have to brake, you have to accelerate, you have to honk, or signal, whatever you call it. You can turn on and turn off the headlights. You have to lock or unlock the car, or open, close the doors, fill up the gas tank, open, close the trunk. You obviously need to be able to turn. And most of these methods affect the attributes of the car. So for instance, acceleration as a method will affect the acceleration attribute, or braking will affect the speed, or turning will affect the vector of the car, in the world. Filling up will affect the gas, and actually accelerating will also affect the gas. One will eat up the gas, make it lower; the other one will increase the gas, make it higher, etc., etc., etc. So this is another example of the difference between a class and an object of that class, because basically you would be able to take this class and create any number of objects which would have the same attributes, the same methods, and then you would be able to populate your world wherever you would need them with those objects, and they would obey the same laws and act in the same way. And one of the things that I saw in the chat, like Vicky saying, can we take a step back and talk about why would you want to program in this fashion rather than using the standard procedural way? And the funny thing is that we're not using the standard procedural way. You think you are using standard procedural way, but in actuality, we've been using this all along because, like I said, Python is an object-oriented language through and through. So everything we've been using was actually objects and methods of those objects. But like, why would you need to create classes? Why would you create objects? And there is no one straightforward answer for this. So this paradigm, came to life, I don't know, in the 60s and the 70s of the past century. And the reasoning behind it was, well, we as humans perceive the world around us as objects and interactions between these objects. So I myself am an object, and the chair I'm sitting on is an object, and the computer monitor I'm staring at is an object, and the tea that I'm drinking is an object from a glass, which is also an object, etc., etc. So if we as humans perceive the world this way, why shouldn't we try programming things the same way as well? Because it's natural for us humans. And this is not the only paradigm you can use to program. So there is functional programming, which is very different from what we're doing right now and discussing right now. And it looks at the world and at programming very differently. The thinking behind all of this is that using OOP makes it easier to program large production size programs, because you have very specific objects which mean very specific things, and you sort of encapsulate the meaning of those objects and the state of those objects and the methods of those objects in one very specific thing, as opposed to having tons of variables that are describing the same thing, but then suddenly you have like 20 variables which describe your car, and you have 20 functions which describe your car described somewhere in the program. But object-oriented programming allows you to actually put it together in one class, and that this class is supposed to work the way a car is supposed to work on your program, or a Mario is supposed to work on your program, etc., etc. So this is not an answer which, after which you go, oh, okay, now I understand why I should use OOP and nothing else, because you don't have to use OOP every time you do something. Some simpler programs or scripts do not require OOP at all. But if you go into some serious programming where you have thousands and tens of thousands lines of code, you'd better start thinking about using OOP to keep it all together and make sense not only to you, but to other people reading your code. I don't know how much that answers your question, Vicky, or as usual, I'm talking too much. So now let's take a look at
okay. We're not going to get more of you after next week, and so you can talk as much as you want.
Thank you.
Just get it out of your system.
Right. So before we go into discussion of the specific syntax, are there any questions or comments itself? Whether the concept is clear or you still have like some icky feeling that you don't understand what's going on. So this is like a good time. I try to explain, my best to explain, but I
have an icky feeling about this all the time.
Right. Is it an enjoyably icky feeling?
No.
I'm sorry to hear that. Anyone else with an icky feeling that you'd like to share? I don't know, maybe half of the people are already asleep from my description. I can only see Dieter and Flora, and Steve say no in the good sense, I hope. Okay, so if any questions pop up, shoot. Let's talk about syntax. So if you want to create a class program you start with a very simple line. This simple line begins with the word class, and then you have a space, and then you have the name of the class. And by convention, as opposed from variables, class names are always capitalized. So that distinguishes a usual simple variable from a class. So in our case, it would be class space capitalized car. And then you have a colon. So this is somewhat similar to a function definition. In a function definition, you have def instead of class. You have the name of the function, but then you usually have parentheses with some parameters. With the class, it works a bit differently. You don't have the parentheses, as you can see. So after you sort of define the name of the class, the first thing you usually do is create something which is called a constructor. So a constructor is a method, and as you can see, this looks very much like the definition of a function. But this definition of a function is located inside the class. So we have the 4 spaces. Remember, after the colon, you have the 4 spaces. And this means that this definition is actually inside the class. So this is defining a method. It just uses the same def word. And double underscore init double underscore is the constructor, which defines what an object of the class will look like when it's first created. So what it says here is that this object itself and is the first parameter. The object being created is the first parameter. Will receive 2 parameters. The first parameter is going to be the brand of the car, and the second parameter is going to be the car. And obviously, this is a very simplistic view of a car. Like, as we just saw, usually cars have many more parameters, but for simplicity's sake, all cars only have a brand and a color, and they don't have anything else. So inside this function, inside this method, to be more specific, we will set the attributes of the object. And I see Vicky is asking, like, can you explain what self is? Yes, I'm going to do that right now. Self means the specific object of the class that we're talking about right now. So while you have the class car, you could have thousands of objects of that class. You can define thousands of objects, much like you can define thousands of integers, thousands of lists, etc., etc. So inside the method, you sort of need to recognize when you are talking about a specific object of that class. And for this, the word self is used by, programmers agree that in Python this will be called self. So for instance, this line which says self.brand equals brand, which sounds like gibberish, it actually means take the specific object being created, the one that we're creating right now, and create an attribute which is called brand, and into that attribute save the value of the parameter brand which is passed into the function. So the reason it's the same word, it's because that's logical. If you want to have a attribute which holds the brand, you would call it brand. And if you want to pass a parameter with the brand, you would also call it brand. But that's not specifically necessary. So for instance, you could change brand here to X, and then you would write self.brand equals X. So whatever X into the constructor will become the brand of the car. The second one will be self.color equals color. So that's the same logic. I want to set up the attribute of the specific object to be whatever is passed into color. So this specific color will be the color of this car. To give you a different look, for instance, I will also create an attribute which is called self-speed, and I will set it to 0. I do not need to specify the speed of the car because I would say, every car object that I will create will initially always have speed 0. I will not create, speeding cars. That's safety. All of my cars will have a starting speed of 0. So for this reason, I'm just saying, this specific this specific object's speed attribute is set to 0. When I create another object, it will have a different brand, it will have a different color, but it will still have a speed of 0, etc., etc., etc. Let me quickly look in the chat. Self is the object. Yes, self is the object, that specific object. Yes. Are brand and color attributes? Yes, they are. Self is the object and color are attributes. Yes and yes. How do we know what we are passing in our objects or attributes? Objects can actually be attributes as well. So you can pass objects as attributes. But the first one, which is called self, must always be the specific object that's being created. So when you look at methods, you will see that all class methods have self, must have self as the first parameter, which is the object we're talking about. So now we have a class with a single method which actually creates an object of the class. So when we actually try to create
Alex,
something,
can you pass in methods, or can you only pass in objects and attributes?
you can pass in methods, you can pass in functions for the simple reason that methods and functions are also objects in Python. But I would not go down this rabbit hole right now because it will just confuse people instead of making something clear. But the answer to your question is yes. So now let's create another method. And the other method I'm going to use, though it has very bad indentation for some reason, let me quickly fix that because I actually don't know why it looks like this. Give me a second. Somewhere I definitely screwed up with this. Give me a second so that I don't confuse you. Yeah, there we go. Let me try this one more time. And let me share my screen again. There we go. So this is the second method, and as you can see, it also has this weird double underscore. All methods that have double underscores at the beginning, at the end, are special methods, or they're called dunder methods. Dunder is double under, dunder method, which are reserved methods for any class that you define. So init is the initializer method or the constructor, while the double score str double score method, it's actually a method that describes what would print out if you decide to print an object. Because the question is, if I create a car object and then I say print car, what would I get? I know what I would get if I print an integer. I would get, the visual representation of that integer. I know what I would get when I print a list. I would get a square bracket, then I would get the values of the list separated by commas and spaces, and then the closing square bracket of the list. But what would I get if I say print car? There is no, how would you describe, what's important to print? How do you print it? And that's where this method comes in, because if you do not have this method, any object will simply print out the memory location where that object is situated in the computer's memory. It will be just a number, like a hexadecimal number, which will give you like nothing information, but that's the default behavior of any object. However, if you define this special method, you can actually say what's printed instead. So in our case, for instance, we could return this f string, and this f string would say a self.color. So this would take the specific color of this object. Self brand, so this would take the brand, at self speed, and I'm sorry to all of the Americans here, but we will use kilometers per hour instead of miles per hour for the speed. So a little bit of confusion. And this would actually print out, depending on what object we're printing, the color, the brand, and the speed of that specific object. So let's take a look at an example. This line, this is outside the class. So this is the actual program. We defined the class. Now we're running a program. I want to create a variable which is called car1. So this is going to be the name of the object, car1. Then I say equal to, much like with, any assignment. So this is basically an assignment. And then I call the class. So I write capitalized car, and inside the parentheses, I write the parameters which I want to send into the constructor. So self is passed automatically. I do not need to pass self. This is done automatically for any object. So the first one, BMW, will be a string which is passed to brand, and the second one, white, will be passed to color. So my question is, what do you think will be printed out after I say print car1? What would actually be printed out on the screen? Any takers?
It would be a white BMW at 0 kilometers per hour.
Exactly. So if we print after this, print car1, you would get a white BMW at 0 kilometers per hour, period. So we defined what should be printed when we try to print objects of this class, so we would get that specifically. Let me take a quick look in the chat. So Steve, you're asking an address in memory. Yes, exactly. All OOP methods are Dunder methods, right? No. So there is a number of Dunder methods which apply to all classes. But then you can define methods which are different for different classes. For instance, jump obviously would be a good method for Mario, but it would be a stupid method for car. So these are not Dunder methods. That would be, separate methods for very specific classes and objects of those classes. For your object car1, what would happen if you don't pass in enough attributes? You'd get an error. It's the same as if you would try to call a function with a different number of parameters that it requires. The function would give you an error, and in this case, the constructor would give you an error. If you pass too little or you pass too much, you would get a message saying like, you are passing 3 parameters, but 2 are expected, or you're passing only 1 parameter, but 2 are expected. So whenever you create this specific object of this specific class, you must pass in 2 parameters, not more, not less, much like with a function. So now let's develop our class a bit. Let's add some non-Dunder methods. So first one, which would be a good one, is a method called accelerate. So we would want our car to, change its speed. We would want to be able to press, the gas pedal and get a response. So as usual, we always have to pass self, the specific object, as the first parameter. And the second one would be speed change. So by how much we want to accelerate, by how much you want to increase your speed. And after that, the method itself would be quite simple. The self speed, so the attribute of that specific object, will be increased by the speed change. So whatever is, let's say I want to accelerate but by 20 kilometers per hour, that would change the speed of my car by 20 kilometers per hour. Very, very simple, very logical. So let's take a look at an example. Let's say now we're creating a second car. It's going to be car 2, which is an Audi of red color. And then remember this syntax. This syntax is very similar to methods that we call on strings, methods that we call on lists, on dictionaries, etc. You take the name of the object, you use the dot, and then you type the name of the method. So remember, like list.append or, list.sort. It's the same logic here. car2.accelerate, and we have to pass one parameter. Remember, self is passed automatically, so we need just pass the speed change. So for instance, we want to accelerate by 60 kilometers per hour. The question is, what would happen if after this we print car2? Any takers on what would be written when we print car2 after we define it and accelerate?
What's your accelerate? And so you're passing in the speed change of 60, and so it would be 60 plus 0, right? And so shouldn't it print 0?
Why
I
would
think
it
it would
print
print
0?
no, I think it
No,
would print array.
60, right?
Yeah, exactly. So the
Sorry, I misspoke.
attribute would change to 60 because 0 plus 60 is 60. And Nancy, you're correct. It would say a red Audi at 60 kilometers per hour. That would what would happen. So we changed the state using the method, and now our car is moving.
So,
Okay, so
Alex, sorry, can I ask a couple questions?
sure,
Okay, can you go back to that slides?
yes.
Okay, so when you're having a method such as accelerate, right?
Hmm.
This is a little bit different than a function because you don't need to have a return for for it to print the new speed change.
Yes, that is true. You do not need a return
Why
because
why is that the case?
it's the same case, for instance, with lists. When you use a list and you use a list method like append or sort, remember those methods also do not return anything. They change everything in place.
Okay.
And in this sense, objects of any class are so if you change something inside its method, that change persists. So
Okay.
you do not have to return anything. But
Okay.
it's a good question. It's a very good question.
Um, and then I have another question. Okay.
Sure.
Um, I don't know if you're going to talk about this like next week or not, but let's suppose, okay, you defined accelerate as a method inside another object, not car, okay? Like
Right.
if you had another object like tank, and then
Sure.
accelerate is inside tank, okay?
Sure.
Um, I mean, okay, which means the car doesn't really know that method accelerate because that method was defined in a different object, right? And so
In a
if you
different
were
class, you mean?
yeah. Within a different class. And so if you were to write car2 dot accelerate, does Python know to look through every single class to find accelerate, or does it only look within the car class? And if it doesn't find accelerate within the car class, it will tell you like no method defined or
Yeah, I
something.
understand. So let me ask you in return. You know, you hate me asking you questions in return, but
Yes.
this makes you think. So,
I can't think today, by the way.
for instance, if I take a list and I try to apply a method to a list like upper, which does not exist for list, what would happen if I say like list.upper, which is a string method, obviously?
You
What
will
do you
get
think
an
would happen?
error.
Exactly, it would tell you that lists do not have an upper method defined. The same would happen to an object of any class. It would look at methods of that specific object, which just means methods of that specific class, and if it doesn't find it, it says there is no
Okay.
such method.
Okay.
So you can obviously have different classes with the same method names because Python would know by the variable name which object of which class you're referring to, and it would
Okay.
look only there.
Okay. And sorry, one other question. Okay. Here you have car2 dot accelerate 60. Okay. And then you say print car2. Suppose like after that line, you write another line, say car2 dot accelerate 10. Okay.
Yes.
And then you print car2 again. Um,
Yes.
would would it update now to 70 miles per hour?
What do you think?
I think it's going to update to 70, but I'm not entirely sure.
You are correct because what would happen if when you do accelerate the second time, it would go into this method again. The speed change parameter would be 10. So then you would have self speed. And what's self speed at that moment? What's the value of that
60.
attribute? 60.
60.
So you would say 60 plus equals 10, which would give you 70. That's what the attribute would be changed to. And you would get a red Audi at 70 kilometers per hour if you
And
type that.
and whenever I see these methods, it's always like very simple, like one line things like, okay, plus something or print something, okay. But in theory, you could embed things like loops and if-else statements
Sure.
and,
Like in regular functions. Yes.
lambdas and list
Right.
comprehension within these
Right.
methods, right?
Right.
Okay.
You can do anything inside these methods that you can do inside any function. So in that sense, they're not different. And the reason why here they're all one line is first of all,
Right,
because it's a
right.
very
I mean,
simplistic example
yeah,
and I need to fit it on a single screen.
right.
So, but yeah,
Okay.
sure.
Got it. Okay.
And I see, Dieter, thank you very much for giving the written explanations for dunder methods or magic methods. So that's why they're called done there, is because it's double on there. It's not A, it's E on the end. And basically, they're just methods which are usually for any class that you define. And you can then change the default behavior by creating a specific implementation of that for your own class. Otherwise, it uses the default. Marcel, the str method, once again, defines what would be printed when you actually try to print an object. Because without this method, you would have, how would Python understand what you want to print when you try to print your car? Python has no understanding of, car. So the only thing it can do it's print the memory address where that object is stored. But you can yourself decide what you want to be printed out. Yes, str is short for string, exactly. So how to stringify your object, exactly. Steve, I think I saw your hand go up.
Yes, I mean, maybe this is a question that's obvious to everybody else. I just want to clarify. If you
Shoot.
have car2 and you want to change the brand, you could write car2 dot brand parentheses quotation marks Mercedes. Is that correct?
Not exactly. The syntax
Okay.
is a bit different. You would write car2.brand equals the string
Oh,
Mercedes.
equals. Okay. All right. All right.
Yes. And we're not going to talk about this today, but maybe we'll talk about this last time, why this is actually a bad idea. There is a concept of encapsulation in object-oriented programming, meaning that you shouldn't be able to directly change the attributes of an object like this, like for reasons of security, reasons of readability, etc., etc. I'm not going to go into this right now. Python will allow you to do this. So Python is not restrictive, unlike many other languages which do not allow you to do this, but it's generally frowned upon unless it's a very simple program. But it's a good question, and the answer is you just use an equal sign, the assignment operator. So question, Marcel, you're saying, use methods to change attributes. Exactly, yes. There are special methods which are called getter methods and setters methods, which allow you to get a value of an attribute and set a value of an attribute. And we will hopefully talk about them next time. I know Vicky wants me to talk about them next time because that's the way it's usually done. Okay, so let's talk about another method, which is decelerate. Because if you want to accelerate, you'd better have the ability to stop. And it would probably be a very similar method to accelerate. You'd say self.speed minus equals speed change. But there is an important addition which you need to make to the decelerate method, which is sort of also important for accelerate, but you can ignore it. But with decelerate, that ignorance would be strange. Any ideas what else we need to add to decelerate to make it, real life, to make it?
I mean, it shouldn't go like below 0, right?
There you go. Excellent idea. That's the thing. Because for instance, if you're going at 60 kilometers per hour and then you say decelerate by 100, what would that mean? Like deceleration, if you press on brake, it does not make you go backwards. You have the reverse gear for that, but that's not deceleration. Although, in Newtonian space, maybe it is, but not with a car. So in this case, you'd need to add some you need to check the result. You would say if self-speed is less than 0, after this change, you set it to 0. And this is an important addition, which you need to, take care of. So if you remember our red Audi, which is traveling at 60 kilometers per hour, if I say decelerate 100, I wouldn't self-speed to be minus 40. That would be factually incorrect. I want it to be 0. And thanks to our addition in the method, that's exactly what would happen. We would have red Audi at 0 kilometers per hour instead of this is everything that I wanted to talk about today. We did go a bit overboard with the time. I thought in an hour, but it's like an hour and 10 minutes giving, whatever's the quizzes and the important information. So before we go into specific assignments, I'd love to see questions, hear questions. I think I maybe missed a couple of. Oh, okay, Dieter, that was you answering. Okay, thanks for helping out with that. Yeah. Anything on your mind that you want to discuss, ask, comment on before we get into, the first one? And I think we should do a class assignment together. This one probably is, you don't need to go into breakout rooms for this one, and then the second one we'll do in the breakout rooms. Let's talking through the circle class assignment, and then if I see any questions, I'll and yeah, going back, for instance, for acceleration, we would also probably have a ceiling, and we would need an attribute called top speed for your car, because every car has a top speed that cannot go past the top speed. So we would do a similar check, unless, we're driving a car from the future in space that can accelerate indefinitely. In that specific case, yeah, that would be the case. So the circle class assignment. We need to implement the circle class, and this circle class has to have two methods. The first method should be get area. This method should return the circle's area. The second one, get circumference, and this method should return, it should return the circle's circumference. So logical names for these methods. So here is an example. When we create the circle, we would provide with a radius. So the circle should have a radius. You can't have a circle without a radius. And then if we print circle get area, we should get the area of that circle, which is, if I remember correctly, pi r squared. Circumference, you should also, take the r, and is it 2 pi r? I think the circumference is 2 pi r. Yeah, it looks like it. So this is like a simpler assignment before we go to the second one. Let me stop sharing and let me open my VS Code and share my screen again. And please shout out that you can see my screen. Let me take a look at the chat. Yes, 2 pi r, thank you. My geometry is not what it's used to be. I had an A geometry in school, but that was the last time I actually did geometry, so a long time ago. I'm not 18 years old like Steve, so I'm older. That was a long time ago. So this is the main function which is given to us as a template in the assignment itself. So we create a circle, and then we need to print two lines with the area and circle. So the question now is, how do we define this class? So let's do this. You tell me what to write, and I'll write it. What's the first thing we need to write?
Class.
Shoot. Class. Goody. And after
Circle.
class.
Circle.
More specifically, capitalized circle.
Capital
This is
circle.
important.
Oh, why do you need the capital?
because by convention, all class names have to be capital. You don't need it, but if you look at our main file, it's capitalized. So if you do not do this, it will not recognize it as a valid class
Okay.
name. So after circle, what else? What's next?
Init.
No.
Oh,
Colon.
Oh, there we go.
oh well.
Okay. Oh, I'm being very specific here. So, but then you do init. So what's the syntax for init?
Dev, dunder, init,
Yeah.
and then parentheses self.
Ooh, is it?
Well, I mean, you have those two lines on the left and 2 lines on the right,
Yeah,
right?
you have to do the second dunder.
You know what I mean, right? Like,
I want you to be very explicit here for everyone's sake. So, okay, so then you have the
you're
parentheses.
intuitively gifted, Belliacop.
I am. I know what you mean, but not everyone is. So I need to, explain for everyone and not just you and me. So we have self inside parentheses. Anything else?
You could do either radius or the diameter, depending on what you want.
So here we sort of discussed that it says so in the assignment, so we need
radius.
to be radius.
Okay.
I mean, we can call it whatever we want. We can call it x, but let's call it radius. Sorry, I heard someone on the audio. Could you repeat, please? If you're saying something.
Someone said pi. Pi.
We do not need to include pi here because pi is not a parameter that we're passing into the constructor, and the reason for that is that pi is not a parameter in the sense that pi is constant. You don't change pi unless you are some geometry magician and your world sort of works in non-Euclidean geometry. So we don't need to pass it. Python would know it. We would need to take it from a certain place, but we don't need to pass it. Okay, so inside, once again, obviously we need a colon. What do we need to write inside the constructor?
Self.radius equals radius.
This is the constructor, and yes, you're absolutely correct. We should say self.radius. So this is the name of the actual attribute. Radius. We could have done this. We could have said x and then say self-radius equals x, but that's not very clear, like what's the x. So let's keep it like this. Okay, we have the constructor. So now when we say, circle 5, we would actually create a circle object with the radius attribute equal to 5. What's the next thing we need to do?
You need to define some methods, right?
Exactly. So let's go one by one. What's the first method we want to define?
Area or get area or something like that.
Get area. Usually if your method, and pay attention here because here the method actually should return something. If your method returns something, by convention, you usually place a get at the beginning. So it shows that it would actually give you something.
Okay.
You want to get
So,
something from.
Alex, here is where I got a little bit confused because based on your prior acceleration example with the car, accelerate did not really return anything. But yet when you like call the object car, accelerate would update. And so I was wondering, do you really need to return area or can you just leave the return out?
The difference is that if you do not have a return, but you actually change something inside, you simply perform a change to one of the attributes. That stays inside the object. There is no need to return anything outside of the object. But in this case, we're actually trying to get the object to give us something, like give us for instance, remember the dunder method str, which prints something. It actually has to return. It says like this is the way my object looks to the outside world. It gives you a description of the object. Without that return value, you would just print none. The same thing here, because we want to print the result of the getArea method from outside the object, we needed to return something. Does that make sense? So it's a difference between internal working, external working. So some things are happening inside method. For instance, if you have a car with internal combustion, you don't care what happens inside the engine. It just increases your speed. You don't need to shout to the world like, yay, my speed is increasing. But if you have a method which is actually supposed to return something to the outside world, like, signaling, you need to press your steering wheel to signal, then you would return something like a string honk honk, so that everyone outside actually hears what you're doing.
So if I understand, when the other one with the acceleration, you changed the object.
Yes.
Yes. And in this case, you're just using the details of the object to get something else.
Yes, to actually provide information to the outside
Okay,
world.
I get it. Thank you.
I don't get it, Steve. I'm like much younger than you, but I still don't get it because my mind doesn't work very well.
What's the thing that, like, where's the block?
I don't know. So, I just don't understand like why in the last example you didn't need the return and this one you do.
Okay, but if you take a look at let me share it again. Remember we had the str_dunder method.
Yeah.
Remember that it returned something.
Not really, but okay.
Okay, it did, because it returned an F string that describes the object. So it says return F and then the F string, white BMW at speed like this and that. So the reason why it returned something is because it actually provided information to the outside world. It's much like a function with a return. So you can have function with return, or you can have functions without return. The function with a return actually gives back something to the calling program. It says, you asked for a description of the car, here it is. But when you're using a method to change an attribute, the outside world actually doesn't expect anything from you. It just expects that the attribute would change internally, but it does not signal this in any way, unless you say, let me take a look at your car again. What speed is this traveling right now? And you say, okay, now it's traveling at 70 miles per hour or 70 kilometers per hour.
But in the car example, we did return something to the outside world because when you print the speed changed.
Right, but you're returning this using the print. So you are using the str_dunder method. You're not using the accelerate method or decelerate method to actually return something to the world. So you have two different methods, one of which affects the internal state, but the second one tells you what happened.
So I guess what Steve is saying is like in the car method, we are actually changing the car. And
Yes.
so here, if you're returning the sort of area, right, you're actually not changing the circle. You're just
I'm
like,
not doing anything to the circle, you're correct.
okay. I
I'm just
kind of get
providing
it. Okay.
information to the outside world. Marcel, I see your raised hand.
Yeah, I was trying to regarding the question that Vicky had. Isn't it just a matter of how we are implementing the class? For example, we could also implement the class circle in a way that inside the init method, the area and the circumference are already calculated, and that it has a SDR method that would return as the area as well as the circumference once.
Yeah, I understand, and you're absolutely right, Marcel. It really depends on how you, as a programmer, envision the the structure of your class, because you're absolutely right. For instance, here we could have done, self area equals whatever, self, circumference equals whatever, and then you could just return those values, once they're called for. The reason why we're doing it the way we're doing it right now is because that's what the assignment asks us to do. So we have to follow this assignment. But otherwise, we could have done it differently. And then this is actually, the implementation is, I think even here we could have done, this calculation once and then just printed it out here. The difference is that in one case, like if we calculate here, we would need to calculate this over and over again each time this method is called. If we calculate them here, we would take up a bit more memory because we would be constantly storing 2 more attributes, but then we would not need to calculate them over and over again. We would just send the attribute because, the area of a circle doesn't change and the size of the circle doesn't change if its radius stays the same. So your idea is on point. You can, use both of these of defining this class. So, and it's up to us to decide how we want to do it. So once again, do we actually want to define the area and the circumference in the constructor, or do we want to calculate them each time, it's asked for? This is an open question. Whoever answers first, that's the way we're going to do it.
I don't think we want to do it in the init because the circumference and the area is always the same, and it only depends on the radius. So we don't want to carry extra attributes around. That's my thing. Thank
Okay.
you.
I mean, we can have a difference of opinion, but you were the first one, so let's keep it simple. Let's calculate it inside the method. So if we have def get area, what next? What else do we need to write? What's missing here? Syntax-wise. Self in parentheses, exactly. So each method must have self. Without self, it would not work. It would give you an error. Is there anything else, any other parameters that we need to pass?
I don't think so.
No, because we can look at the main, and in main, there are no parameters. So self is the only one because it's passed automatically. So what's in the body of the method? What do we write here?
Then you need to do math.
Okay. What do I have to do in order to do math?
I think you have to write something like like maybe self dot radius multiplied by 2 and then multiply that by whatever the value of pi is equal to area, and then you return area, right?
Someone else. Yeah, it says my connection is unstable, so I think I lost it for several seconds there. Could you repeat it, because I lost you at self.radius
okay.
multiplied by...
How sad. Okay, self dot radius multiplied by 2. And then wait, the area. How do you calculate the area of the circle?
Can someone else jump in? How do you calculate
and
the
then
area?
you multiply by pi.
2 pi r. So no, 2 pi r
That's
is the
just
circumference.
This is pi r squared.
Oh yeah. God.
Oh, so it's actually pronounced circumference.
Circumference, yes.
Okay, so that's what happens when you read a word but never pronounce it in your life. So now at least I know circumference. I've always thought it was circumference.
Okay. Like interference.
So we have self-radius multiplied
by self-radius again.
Okay, but we can actually square it. Like we have
Okay.
Okay, and multiplied
by pi.
Okay, if I write pi, I would obviously get an error because Python does not know what the variable
Well,
pi
you could just
means.
type like 3.14 as an approximation, right?
But if we want a specific number, what can we do? Because this is actually
You have
written
to
to the
import
assignment.
some like math module.
And let's do that. Import math. And then,
I'm not sure how you call pi. I mean, would you just call like math.pi or something?
yes, because it's saved as a
Dieter,
constant
you can
inside the
talk.
math
You don't
module.
have to nod because other people can see you nod.
I don't see you nod actually, because I only see one person who is talking. So if you're nodding, I do not see that.
See, I
Okay, so
take
we
my
have,
hint from Dieter, okay? I mean, if like Dieter nods, I continue. If he doesn't nod.
okay, so we have self-radius multiplied by path pi. What do we do with this?
Oh, and then you have to set it is equal to area or something like that.
Okay, do we really need to? We could.
Well, okay, if you don't set it to area, you could just put all that in a parentheses and then return it.
You don't actually need the parentheses because return doesn't
Oh,
require
yeah.
parentheses. So we can do like this.
Yeah.
No need to create an extra variable. Okay, that should work, hopefully. Let's quickly do the other one because, yeah, we don't have that much time remaining. So that one is get circumference. Do I pronounce that correctly? now?
Circumference.
Circumference. God, I hate English sometimes. Like
Alex,
circle.
keep it as circumference. I think it's better.
Circumference.
I mean, the accent is on the second syllable, okay?
Yeah, I understand now, but that's not an easy word to figure out how to pronounce because English is
Circumference.
circumference. Okay. All right, so
It took me at least a decade after moving here.
there we go. So it's also just takes in self, obviously. So what do I need to return here?
That would be self.radius multiplied by 2 multiplied by math.pi.
Okay. And I think we're done with this one. So, but let's check and run and see that it cannot import name circle from circle. And I'm going like, I didn't save it, sorry. I need to save this and run it once again. And why am I, hold on, get area print. Okay, this is obviously, I'm just wondering why do we have this problem. There we go, so we have the area 78 point whatever and the circumference 314159 blah, 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 whatever, what have you. And I think these are the numbers that we're supposed to get. We can check. Do we have them here? No, we have them. Yeah, that's the number we're supposed to get. Okay, so we are done with the circle class. I think any questions on this one? Anything that's bothering you with what we've done so far? I mean, this is not the best example of, you know, how you would use object-oriented programming, because your question is why would you need an object for a circle in this specific program? But it gives you, at least gives you, you know, look at the basics. The second one I think is more interesting because it's more usable, it's more hands-on. So let me share my presentation again. And here we are. So the second one is the class. Those of you who haven't seen the assignment could go like, why are we saying class twice? This is because we're going to create a class for a class in a university. So that's a repetition on purpose. The key is that we need to implement the class with the following methods. First of all, we need to create an init method, so we need to construct a class with a certain number of parameters. Then we should have an add student method, which takes in a name and an ID of that student and actually adds such a student, you know, to the class. with a given name and ID. We need to define a get ID method, which takes in a name. It looks through the student list, and if such a student exists, it should return the student's ID. If a student doesn't exist, it should return -1 to signal that there is no such student. And the third one is the get class list. So this is a method which should just simply return a list. So a list in the sense type, a list of the names of all the students, just names, no IDs. It should be a list of names. So this is it in terms of the assignment. That's actually the last slide of my presentation. If we go back to VS Code before we hit the assignment rooms, let's quickly take a look at what the structure of that program is, because we are given that structure in the assignment itself. So we will have a main file which actually creates the class, adds students, and then expects certain things to be printed out. And then we have a blueprint for the class, which we have the 4 methods we just discussed. So the 3 methods tell you what needs to be done, but the constructor method, you actually have to yourself come up with a decision on what a class would have in terms of attributes that we're going to pass to it and save when we create each object of the class. We have about 20 minutes until the end of our session, so I should think we should, spend 15 minutes on working on this in breakout rooms, and then quickly go through it once everyone's back and write this class.
Well,
unless there are questions, of course.
well, I mean, do people just want to do it together as opposed to breakout rooms?
I don't
Yes.
know. We could okay, the lazy people are saying yes, of course.
Well, if you want to do it together, why don't you just put in like a hand in the chat, and then we can see like, how many people would prefer to do it together. That way we won't keep Alex over time either. I see one hand.
It would certainly be quicker. That's for sure. Blossom is raising her hand as well.
Do the rest of the people not care, or are you just like zoning out?
That's the problem with asking such a question. You would either need to poll people, or some people do not care.
Okay.
So.
Do not care. Do you have a preference, Alex?
I mean, if people want to do it together, I don't mind doing it together. Let's do this then.
Okay.
All right. So like Flora is saying that I'm not sure what you're asking, so I don't dare saying insanities for the sake of something.
It's okay. I say insane things all the time, so
I'm sorry that you're not hearing us well, but maybe you'll be able to see the recording when you have your earphones fixed. Anyway, okay, let's do this together. So let's top. If we have the constructor, which should create a new instance of the class, the question is, what do you think should be written inside the constructor?
Don't we need to pass? Oh, I'm sorry. Sorry.
No. If you have questions, ask. I'm just saying, if you look at the main file, then you will see that nothing is passed inside the constructor. So class goes with empty parentheses. So obviously there is nothing except for self here. Right. So the question is, what do we actually create?
You probably need a dictionary, I would guess, because and then your key would be the name of your students, and then your value would be the ID.
Okay, right? This is probably one of the ways we could do it. Any other thoughts on, any alternate ideas on how this could be done?
I mean, you could also probably have as separate attributes like name and ID.
But then that's the class that would have the attribute. You would have a class that
What
has
about,
a
I'm
name.
sorry.
No, go on.
Well, since you're asking for a list and the last thing, why don't we start with an empty list? No?
That's the second way you could do it. Obviously,
Yeah, okay.
you could do a list of students. You could do a dictionary of students,
Uh-huh.
and the fact that we're actually printing out a list does not mean that we have to store it as a list.
Mhm.
We can, we can decide ourselves how to format it before returning it to the calling program. And I actually, to be honest, I actually like the idea of a dictionary because I think it will have less overhead than a list. Because inside the list, you would then have to have a sublist, or you would have to have a list of dictionaries which describe each student separately, or tuples, or So I would actually try doing it as a dictionary. So Vicky, since this was your idea, how do we call this dictionary?
You would always start with self dot, I would call it students, and then
I think
define
that's
that as
good.
an empty dictionary.
There we go. So do we need to define anything else in the constructor, or this is enough?
I don't think so because the name and ID can just go into your dictionary, I think.
Okay, but I actually like Mamina's comment in the chat because probably the ID should be the key, since names can be theoretically repeated. You could have people with the same name,
Right.
but you cannot have an ID. So this is a good idea. Let's go with that. Let's say I'll write this comment: ID as key, student name as value. This is like student ID. Okay, so let's start with the add. Move on to the add student method. So here we need to add a student. Obviously, we have the name and the ID passed in, and we need to add a student by that name and the ID to the class. How do we do this?
It would be self dot students, and then rectangular brackets. The key, which in this case would be ID, is equal to name.
Okay, so this sounds logical since we're using ID as the key and the name as the value. That's exactly what the syntax would look like. Any thoughts on what else we could do here? Do you think this is enough, or maybe we need to add something else?
I think it's enough. I'm not sure what else you would add, but
Maybe it would make sense to check whether the ID that is
Yes.
passed already
Yes.
exists.
Right, Marcel. So, and I see Tony, you're writing the same thing. So it would be good to check whether the ID exists, because if the ID already exists, it means that we're risking overwriting data that we already have. So I would write something, if ID not
in
self-student,
student.
then we do this. The question is, what do we do otherwise? If it is, and there are different ways we could do this, but I propose right now not to.
You could write break.
Break would not accomplish anything here because there is nothing to break from.
Okay.
Right now, it would do nothing. So in this case, it would do absolutely nothing. But you could, for instance, raise an error, which I'm not going to go into right now. But ideally, you would raise an error and say, like, this is wrong. This is not supposed to be happening. Okay, let's stay at the. So next one is get ID. With get ID, remember, if we have get, that means that the method has to return something. We get a name as a parameter. We need to return the ID of the student if it's in there, or -1 if the student isn't in the class. How do we proceed here?
It would say if name in self dot students, colon. And then
in self.students like this.
let's see. Yeah. Okay, so it returns the ID of the student with this name. Okay, so I think the way that we have it is backwards. Because if we have the ID as key, oh no, wait. Returns the ID of the student with this name. Because based on the way that the assignment is phrased, okay, it would have been easier if you use the name as the key and the ID
Sure,
as
sure,
the,
but I agree completely with Mamina and I that you can have the same name, so we need to find a workaround.
yeah,
Having the ID as the key is correct.
so so here you want to return the ID, um if name, wait,
So this statement now looks through the keys. Self.students is
Right.
the keys.
So
So
this one would not work.
these are
right.
just numbers. So we have to actually loop through the dictionary until we find that name.
But how can we do this with a dictionary? How can we look through not the keys but the actual values?
It would be student
Self.students.values
dot
method.
wait, self dot
Yeah.
student, yeah.
Dot values. That what I'm not sure who Marcel. I think you said this that you go self students values. So this would give us an iterator with all the values. We would go through the values and see if the name is in there. But then the question becomes, what do we do once we? Obviously, if we do not find anything, what do we write here?
Return minus
What's-
1.
Yeah, here is return minus 1. What happens, here? And this is obviously, here's a gray area, but what happens if you find two of the same names and
Right.
different IDs, and then you go, I have no idea what happens in this case. Obviously, whoever created this assignment didn't even think of this possibility, unlike, we did. But let's say, like, the first one that we find, we return it. How would we approach that?
I mean, would you write like return self dot students dot key?
What's key? We don't have key.
Well, it would be the key corresponding to that value, right?
Right, but we don't have that key at the moment, so we can't write key because there's no key.
Can we
Um,
use
No, the
names?
Names? You mean name?
name.
Yeah, name.
But name is a value. It's not a key, so it would not recognize. Remember, the keys are IDs, and this would simply return the name of the student. So we pass in the name and we get the same name back. We need to get the ID. Maybe we need to create a reverse dictionary.
Yeah.
We could do that, but then we would risk, several values overwriting each other. So in this case, unlike in the cipher we did, a reverse dictionary would either have to have, like lists of IDs for each name, or we would risk losing some data. But I mean, let's think about it. If we know that the name is in there, how can we find the key to that name?
We can write the for loop and look at every key value pair.
Okay, so how do we do that?
For ID, comma name in self.students.items. Oh, we have name and name. We need to name it something else.
Okay, that's good. Yeah, let's name it something like, I don't know, like name underscore.
Okay.
So what would we write then?
So if name equal name underscore. return ID.
Right.
Yeah, exactly. So this would return the ID of the first name that we encounter in case we have several. This will give us some value, and then we don't really need the else because return -1 will happen if we go through the entire for loop and there's nothing there. Then it will return -1 automatically.
Had you raised hand?
Amina, did you want
I
to
think
ask
it's
something?
better
Because
to keep the name as a key, because then if no, I'm think on second thought, I think it's better to keep the name as a key, because then all the IDs associated with that name, we'll get all of those. If there are multiple students with the same name, then we'll get all the IDs when you asked for get ID, when you
sure,
run get
but
ID.
in this case, you would probably need to create a list. So you would go something like ID list to
No,
list.
I mean, in the first case where we kept IDs as keys, we should have kept name as keys, like Vicky suggested first.
You mean here?
So then each name can hold multiple
No,
IDs.
I think
Yes, and each name
what
can
she was saying is it would have been easier if we
To
had
have
done
names
the
as keys and IDs as
yes,
values. I
yes.
understand that perfectly. But like I said,
because
since
then
we
you
already
would get
did,
all the IDs with the name.
yeah, but it would give you sort of the same thing as we would create here, because then here you would need to create a list for each name, so you'd have as many lists as names, even if that list has only one value. Here, we only have key value pairs. They're both integers and strings. And here, for instance, you could do then, you could do like ID list. Initially, it's empty. And then for each name that's equal to the name, you would simply say ID list append name, and at the end you would return the ID list. The only difference here is that then you would need the else to return -1 instead of an empty list, because otherwise it would return no, it would return -1 anyway. So yeah, we don't need the else.
But
So
if
this
we
is the way.
if we return a list, it would be better to return a list in any case, not an integer -1 in one case and a list in the other. So we should return an empty list if we do it this way.
Probably, I think that would be logical to have the same data type at least returned. So in this case, I would prefer to return an empty list, and then by this the ID here. Hold on. So yeah, so basically would be going only through names. Is that right? We wouldn't need the ID. No, hold on. We would need the ID, of course, because we have to have ID here instead of name. So this should work, hopefully. But we'll see when we finish everything. So we'll see how it goes. So what about the final one, get class list? Let's do this one. It should return a list of all the names of all the students enrolled in the class.
So for this one, you need to create first an empty list.
No, you don't. This can be done in one line, very simply given the
Oh,
structure
oh,
of
oh,
our.
oh, oh. Like you could do a list comprehension?
You don't even need list comprehension, although you could do it.
Okay. So, is it like if you have, okay, right now the names is still the key, right?
No, the names are the
Oh,
value.
no, okay, sorry. And so do we want like for student in self.student?
We could do it like this, but we can. There we go. The guys are writing in the chat, saying, "Can we
Oh,
return?"
values.
the values, but we could, but then values is actually a very weird data type. It's not what you would expect. We would need to turn that data type into what? What's the final result that we need to pass back?
We want a list.
Yes, how do we turn it into a list?
Calling the list constructor.
We can use the list function
Yeah.
and say yes, exactly. So
What the heck is a list constructor? I don't remember this.
Sorry, a list is an object, and so when you define a new object, you call the list. It's like a class that we're defining an object of.
but basically, yeah, we can take self-students values and then apply list to that object with values, and we would get a list of all the names, and that's it. We don't need the for loop. We don't need the list comprehension, although I like that you remembered list comprehension, but it's unnecessary here. We can do it like, hopefully.
I was
Let's
trying to
save-
practice my list comprehension, Alexander.
Good, and I think you should do that. I think
You
that's
should
very
applaud my effort.
commendable. Oh, I do applaud. So let's run the main file and see whether we get what we're supposed to get. Okay, so first one, we are supposed to have Muhammad, and we do. And then the next one, we're supposed to have Muhammad and Elise, and we do. But then the third one, when we're supposed to get -1, and in our case, it's supposed to be an actual empty list. We decided it's an empty list. For some reason, it returns none. So obviously, line 10 is not doing what we wanted it to do. The fourth one also returns a list, and this is good because it returns a list with a single ID number that is obviously Muhammad. So let's take a quick look. Why is this incorrect? Whoever gives me the quick answer wins.
What's not correct?
One more time. Line 10 returns none. This is incorrect behavior. It's not supposed to return none. It's supposed to return, well, we were asked for a -1, but we decided to do an empty list. But obviously it does not return an empty list. It returns none. What's the reason why it returns none?
There's an indentation error.
Exactly. In which line?
I won't tell.
Peter.
Can someone tell us where the indentation error is?
Line 30?
Yes. What is the indentation supposed to be?
Should it be more left?
It has to be here, because without this, it's inside the if.
Yeah.
And since this if fails, the function doesn't return anything. And when a function in Python doesn't return anything, it actually returns the special value none. Good job, Vicky. So let's run
I
this
needed
again.
Dieter's help.
Teamwork.
I gotta like carry Dieter with me.
So there we go. We have an empty list, but the only thing I think we're not actually checking the this is 1 of 6a. We're not checking the total list of students. Are we? Or are we? Oh, we have it here, get class list. Okay, we are checking it. So I think
Can we try something else? Let's define a second Muhammad with a different ID and see if it works.
Okay, I think this is a good idea. So let's
Define a second Muhammad.
Why is that funny?
Well, I was just thinking we should change all the Muhammad to like Dieter. Define a second Dieter. We can like clone
I think
Dieter.
Muhammad is the most common name in the in the Arabic world. So let's this be the ID. Does that work? Should work. Let's see what makes our program or not. Okay, so you see we have Muhammad, and then we have Muhammad Elise and the second Muhammad. And the thing is, though, when we are trying to get the ID for Mohammed, it's only the first one.
Right.
So this is a good, testing exercise. Thank you, Dieter, for proposing it, because at the moment it does not work the way it's supposed to do. So once again, let's see where we screwed up and why it happened. If key is named, then get ID simply checks if the key exists and return the IDs which are stored as a list and add student.
Like an indentation, we're returning as soon as we find the first one instead of going all the way.
There we go. So we actually need to go back here. So we had 2 indentation errors in here. And if we save and we run this once
You're
again.
so smart, Dieter.
Very
How do you
smart.
catch
So
these
now,
things?
now we get the second one, but we don't have the first one.
But we're not getting the first one.
So why is that the case?
We have to define the list before we start the loop.
Otherwise, we are defining it inside the for loop each and every time as an empty one.
Vicky, you see, I see those things because I stumble over them all the time, and that's how you learn.
You must do this a lot. Because I mean, you must like sleep and dream about these things, okay? Like for me, after 9 o'clock,
There we
I'm
go.
like, I turn into a pumpkin. I don't care.
There you go. We have both. So we actually did some nice debugging, thanks to Dieter's proposal.
I know,
Thank
thanks
you,
to
Dieter. And I think we're pretty much done with what we're supposed to do today, and we're only 4 minutes over our time limit, so yay! Good stuff. Any final questions before I log off? Comments, questions?
Thank you.
And thank you, everyone.